Okay, we're just gonna continue on. So we have a couple things. Let's talk about the enzymes first. So we have a few enzymes, alpha amylase, and that breaks alpha 1,4 bonds, and we have glucoamylase, which is, so alpha amylase I think is found in the saliva, glucoamylase is found in the GI. We have sucrase isomaltase. This breaks 1,4 bonds, but it also breaks 1,6 bonds, and it's the only one that breaks 1,6 bonds, so we kind of need it. We have trihalase, breaks 1,1 bonds. He said in the video that this is like associated, like if you eat a lot of mushrooms or something like that, you need this one. And then lactase breaks beta 1,4s. Couple notes, so fiber cannot be broken down, or cellulose is the sugar, right? We're recommended to have 25 to 38 grams, and that's because it increases GI motility, so you're able to move stuff out of your GI tract. Intestinal flora can digest carbs that don't get digested. So because of that, you get methane and lactic acid. And I mentioned that again in the carb intolerance. Excuse me. So carbs that don't get digested become digested from bacteria or the flora, and it leads to lactic acid, bloating, and then methane, right? Gas. And then another note to have is that we have onset lactose intolerance. So just as we age, it's harder for us to be tolerant to lactose. Okay, so this is probably the hardest part, hardest thing to describe from this module. So I'm going to talk about what's going on here, and then I'm going to talk about the transporters. So here we have the SGLTs, they're sodium dependent. So we have to have sodium coming through to be able to get the galactose and glucose through. So those go through this purple one. The red one is specific to fructose, and so that's GLUT5, and it allows fructose to go through. We have GLUT1, which can allow glucose to go through as well. And I wasn't sure if GLUT1 also entered the capillaries, but I know that GLUT2 does. GLUT2, as I'll say in a second, it's bidirectional, and it's based off of pretty much, not osmotic pressure, but something close to that. And then this green guy is like ATP is allowed to be churned here, and sodium and potassium. I don't know how important that is, but I just threw it on there. But so here's food in the intestinal wall, and it travels through, gets the glucose to go to the capillaries, okay? So GLUT1 is for the red blood cells, but pretty much you can think of blood-brain barriers for GLUT1. GLUT2 is bidirectional, so it can go either way. GLUT3 is for the brain. GLUT4 is insulin dependent, and it's mainly for skeletal muscle. GLUT5 is for fructose, so think of like if you spell out 5, you have an F, right? So F and fructose, and he mentioned that it helps with sperm. So these are the two sodium dependent guys. So we have the SGLT1, and that's mainly in the intestines, and then we have SGLT2, and that's mainly in the kidneys. So both the intestines and the kidneys process sugar. And then the last note is that after you eat, blood glucose will rise for 30 to 60 minutes, and then it will return back to its baseline after about 2 hours. So that's pretty much this module.